Okay, thank you for the invitation to speak here today. I also want to thank my co-authors who have contributed figures and slides to this presentation. I want to talk about the WMO annual to decadal multi-model ensemble and how that might be applied to predicting climate hazards and extremes. So just as an introduction, I saw in Nature Climate just a couple of weeks ago, there was a study, a meta-study on looking at people who are already affected by climate change, and it turns out 85% of the world's population already live in areas that experience the effects of climate change, which is, it's quite a lot already. The World Economic Forum Global Risks Report has pointed out that extreme weather is one of the most pressing global challenges, and that a single event can be quite devastating. And for this, one of the helps to mitigate this is climate information. So there's a global framework for climate services, which has existed for a while, to provide kind of helpful climate information about what's happening with climate change and in the near future, seasonal to decadal kind of timescales. They have the potential to give early warning of particularly extreme events. And now, we've been working both with seasonal and decadal predictions for a while now, and we know that large ensembles are necessary to capture important climate signals. And one of the easiest ways to get large ensemble is to use a multi-model ensemble. So in 2017, the lead center for annual decadal climate prediction was established, and to help with this climate information. So what is the lead center for annual to decadal climate prediction? It started as an informal exchange of decadal predictions, so 1 to 5 to 10 years out into the future, and just to compare forecasts and make a large kind of consensus forecast. And building on this effort, as I said, the lead center was then established in May 2017, and the lead center prepare forecasts annually from the data collected from the different contributors around the world, prepare verification statistics of the multi-model and of the individual models, and make available up-to-date information on the decadal prediction systems like resolution, initialization methods, etc., and create a global annual decadal climate update, which is our consensus forecast. So this is all available if you go to this website on the screen. So the climate update, what's this? Well, it's issued every year by the lead center. It has data from many different contributors around the world. You may recognize some of the acronyms there. Does climate predictions for the next 5 years, so not projections, but predictions. As an example in the figure here on the right of the slide, I'll talk more about that in a minute. Also looking at indices, looking at probabilities. So here we have a calculated in the latest issue the 40% chance of exceeding 1.5 degrees temporarily, exceeding 1.5 degrees in the next 5 years. So that's 1.5 degrees above pre-industrial. Now this is quite high profile, lots of press releases, lots of media pickup. So it's definitely something that's getting out into the world and being seen. So just to say a bit more about some of the key outputs of the climate update. So this is an example of an index which is in the climate update. This is global mean near surface temperature. You can see various skill scores on the right, both for the ensemble mean and for a probabilistic forecast. And then on the left, the blue kind of shading is the actual forecast, and the green shading are past forecasts or hindcasts, and then the black line is observations. So you can see how well we've done in the past. And the brown bars around here at the bottom, let me get a laser point. The brown bars down here show the exceedance probability of 1.5 degrees above pre-industrial in the 5 years following, well, including the year where the brown bar is. So this is for 2021 to 2025, which is where we got the approximately 40% chance that one of the next 5 years will be 1.5 degrees warmer than the pre-industrial levels. Is, however, unlikely that the 5-year mean will be above 1.5 degrees. So we're not talking about permanent exceedance of 1.5 degrees, we're just talking about temporary. But the chance of at least 1 year exceeding the current warmest year, which is 2016, in the next 5 years is 90%. So we're almost certain that we'll have another record in the next temperature in the next 5 years. We also have maps to be able to do kind of more regional forecasts. You can see there's surface temperature, sea level pressure, and precipitation. And on the left of each pair is the ensemble mean forecast, and the right is the probability of above average. So, for example, looking at the surface temperatures, there's a high probability for above average temperatures almost everywhere. And in the Arctic, north of 60 degrees, the anomaly is more than twice as large as the global mean anomaly. So it's what's called polar amplification. Also interesting is we have warm temperatures in the tropical North Atlantic. We have low sea level pressure. And the precipitation, the ITCZ, is shifted north. You can see it has an impact on Sahel precipitation as well. But those kind of three indicators together indicate that there's an increased chance of tropical cyclones in the next 5 years, which talk more about in a minute. Obviously, we have to show skill maps as well. Can you trust how good are the models at predicting these things? So this is very similar to other multi-model decadal prediction skill scores. But the skill is high for temperature almost everywhere, apart from Southern Ocean and Eastern Pacific, but it's high in the Arctic, so we have kind of high confidence on the polar amplification is going to continue. So stippling, by the way, is where the correlation skill is not significant. So sea level pressure, there's a lot of areas which are not significant, but the kind of low we saw partly in the North Atlantic subtropics is actually significant, and it's kind of this rainfall, which is indicative of where the ITCZ is also significant. So we have good confidence in our tropical cyclone prediction, as I said. So with that brings me to more about climate services. Because all the research we do has to become useful to be able to help people cope with climate change. So a climate service is the provision of climate information for use in decision making. It's kind of the most simple definition. Can be many different things. Can be like we've been talking about, an effort to reduce the impact of climate variability and change on vulnerable populations. But you can also use it to regulate an industry, or even in a very positive sense, used by a single company to reduce losses and maximize profits. A climate service, importantly, must be developed together with an end user. There's no point developing something we think is good and then trying to find a user for it, because with experience shows that we've done it wrongly, that it's not useful. But let me talk about a prototype decadal climate service, which is being developed at the Met Office under a Copernicus project, so the Copernicus Climate Change Service. It's for the insurance sector. The partner is called Willis Re. They work in the reinsurance industry, and they're interested in tropical storm activity because one of the biggest losses every year is if a tropical cyclone makes landfall in North America. So I talked a bit already about the fact that we can predict tropical cyclones, and there's actually a long literature going back to 2010, more recently 2018, a couple of figures here. So we know well that in decadal forecasts you can predict a kind of long-term changes in tropical cyclone numbers in the North Atlantic. This service here uses, so this smaller box here is called the main development region, which is where the tropical cyclones and hurricanes develop. And we use the SSTs in this box minus the tropics-wide. This is a well-known index for those in the business. Just to say that we could use lead center data to do this, but currently it's a subset of the models which have been used in this study. So how do you use that index? So we've got the forecast index, main development region minus tropics, and done a scatter plot against actual observed hurricane activity. And you can see they fall nicely on the line here with a high correlation, almost 0.8. So we think there's skill here, and so you you can take our latest 21 to 25 forecast of this index, and it's this red dot here, and you can place it and read off just vertically what we think the hurricane activity can be. And the scatter around the line of previous hindcasts gives you kind of uncertainty bars here of the forecast. And as you can see, next 5 years going to be very active in the North Atlantic. Probably one of a top 5, very likely to be a top 5 event. It could be even a record 5-year period. But as I said, this is not always useful for the end user. It's interesting for us meteorologists. The insurance company wants to know how much loss are we going to make. So we tried to use the same index, but instead of correlating it against hurricane activity, we correlated it against the total damage. So how much damage the storms cause in this year. And damage is a kind of non-linear variable, so we've actually correlated against the log of the damage, which is why the shapes and the uncertainty bars look a bit strange here. But again, the method is the same here as 21 to 25 compared to the other years. And you can see now again, it looks like there might be a 5-year period where the insurance company is going to pay out definitely more than average, and maybe good chance of it being quite a high amount. So this is useful for the reinsurance company to make sure they have funds available and are ready to pay out when the insurance claims come in. So to conclude, decadal prediction, and that is a very useful thing right now for mitigating climate extremes. The climate extremes are already happening, as we've seen in many talks already, and I think there are some talks coming up today. And to do this, we need large multimodal ensembles. I didn't say, but the one we used here for the from the lead center has over 100 members, and the scale just keeps going up with ensemble size. So the lead center produces a climate update every year. So we have a consensus forecast, which is published quite widely, and there are now existing climate services being developed using decadal predictions. So I hope that was interesting for you all. Now I'm ready to take comments or questions.